Hey guys, welcome back. This is going to be part 2 of the charge notes for physics. The one unique thing about charge, and we're going to find out that it's something that that shows up a lot in science when you start looking at things at the very small level, is that there's a smallest amount of charge that I can have. And all other charge exists in amounts of that. And because of this, we say that charge is quantized. And so all of the charge of anything is made up of increments of this quantized charge, this elementary charge, I should say, which is 1.602 times 10 to the negative 19. So with our example here, a pith ball has a charge of 1.28 times 10 to the negative 18 coulombs. How many excess electrons does this represent? And so we're saying that one electron is this 1.6 times 10 to the negative 19. And again, I leave off the 0.02, but it'll depend on what your professors do. There's always a little bit of rounding. And so if I divide this out, and again, it's good for you guys to practice actually putting this into your calculators. I get 8. Now, if it was 8.1, this would be an impossible charge. If it was 7.9, it would be an impossible charge. So it's only going to exist in these quantized amounts. And this is something that was discovered by Robert Millikan. And he actually used, believe it or not, F net equals 0 to do it. And he was balancing things with charge and with their weight. And he saw that he only had charges locating at an increment and then nothing, a big gap in the voltage, and then another one at double, then a big gap, another one at triple the original, a big gap, another one at quadruple. And it made him believe that this was the quantized amount of charge. And actually the mass to charge ratio, they discovered using F net equals mv squared over r. So simple physics to find these things out. Now, the actual experimentation, especially for the oil drip experiment, is painstaking. But so we can only have these values. That's what this quantization means. So it's all going to go up by increments of this. So 2 times 10 to the negative 19th, impossible. 4 times 10 to the negative 19th, impossible. And this was a big discovery. So Robert Millikan, who won the Nobel Prize in physics. All right, 2 pith balls are separated by 0.025 meters. One has a charge of 6 microcoulombs, the other has a charge of negative 6 microcoulombs. What is the force between them? So you can either talk about what's going on at the molecular level, which I have you guys do in the fact, or you can talk about the charges on objects. And if you talk about the charge on objects, since the amount of charge is so many electrons, a vast amount of electrons, the amount of charge you're going to have is going to be way less than 1. And so in this case, we're dealing with the prefix micro, which is 1,000,000, which is 10 to the negative 6th. But it would also be common to deal with nano, which is 10 to the negative 9th, or pico, which is 10 to the negative 12th. So again, I'm going to leave out the charge sign. I'm going to write down my equation that is Coulomb's law. And again, instead of writing out the micro, I put in the 10 to the negative 6. So I'm going to put this in my calculator. And I have 518 newtons. So that's actually a pretty big force, right? And we're talking about very small charges. Now, since one is positive and one is negative, this is going to be an attractive force. They could also ask you to figure out how far things are apart. So you're not always just going to look for the force. In this case, they give us the force. We know the constant. We should know the charge. They want to know what R is. So looking at my original equation, I'm going to get R by itself. So I'm going to multiply both sides by R squared. Over here, R squared up here and R squared down there would cancel out. Then I'm going to divide by FE. And then I'm going to square root. So I have 9 times 10 to the 9th newtons, meters squared, coulomb squared. Remember that this quantized charge is both the charge of an electron and a proton. And our original force they told us was this 1.6 times 10 to the negative. And again, this would be good to practice to put into a calculator because that's mainly where the errors would happen. And I get 1.2 times 10 to the negative 10. And that's our average atomic width, right? It's of the order of 10 to the negative 10th, an angstrom. You ever see that? That's a angstrom. All right, so I'm going to do a couple practice problems with you guys, and the answers are in the notes if you want to do them on your own. Consider two clouds of opposite charge equal to 1 times 10 to the 5th coulombs if they're located 7 times 10 to the negative 11th, 7 times 10 to the positive 11th apart. Wow, what is the magnitude force between them? Big charges, big distances, huh? These are from a workbook from the old honors physics. I'll get them set up for you guys, and I'll let you try them in your calculator. Because the answers are on there. Two protons each have a charge of 1.6 times 10 to the negative 19th. They're separated by 1.3 times 10 to the negative 5th. Calculate the force between them. And again, I just scored that because it's the same charge, just like I did with that one. Two equal charges have an electric force of 2.4 times 10 to the negative 6 newtons between them. They are 3.39 meters apart. What is their charge? So in this case, I'm going to get Q by itself. They are equal charges. So I can rewrite this as K Q squared over R squared. So Q1 and Q2 are equal. That's important. I'm going to multiply both sides by R squared. I'm going to divide both sides by K. And I'm going to square root. So see if you can put that in your calculator and get the correct answer. Two electrons each have a charge of negative 1.6 times 10 to the negative 19. They are separated by 1.2 times 10 to the 7th meters. What is the magnitude of the force between them? So it's a straight plug and chug. Again, I would leave the sign out and I'd worry about what the direction of the force is. They're asking us for the magnitude. So sometimes you'll even see that this has absolute value around it, that has absolute value around it, because we're always going to get the direction of it from the sign. So see if you can put that in your calculator and get the correct answer. The electric force between two electrons is 2.6 times 10 to the negative 15. How far apart are they? So we have so again, I'm going to multiply both sides by R squared. I'm going to divide both sides by FE. And I'm going to square root. So I'm going to have 9 times 10 to the 9th. I'm going to have 1.6 times 10 to the negative 19. And I'm going to have the 2.6 times 10 to the negative 15. And again, leaving the negative out means that if you're dealing with radicals, you're not going to have to worry about all that trouble, right? So that can be a problem too. Small quark with an excess of positive 6 microcoulombs is placed. I'm going to erase this a little bit. I think it's 0.12. Yeah, 0.12 meters from another quark, which carries a charge of negative 4. What is the magnitude of force between the quarks? Is it attractive or repulsive? Well, right now I can say it's attractive, right? MC Scat Cat tells us that opposites attract. So one's positive, one's negative. They're going to be attracted. How many excess electrons are on the negative quark? How many electrons are on the positive quark? All right, so first let's get the force between them. And again, I need to take into account that prefix. So I have 6 times 10 to the negative 6 coulombs. I have 4.3 times 10 to the negative 6 coulombs. And I have 0.12 meters squared. It's going to give us 16. And then how much excess I have, right? We're saying that they're starting at neutral. I'm going to say that I have 6 times 10 to the negative 6 coulomb. And I know that one proton has 1.6 times 10 to the negative 19 coulombs. So these will cancel out, and I'll be left with a number. And then for the other one, I have negative 4.3 times 10 to the negative 6 coulombs. And I know that an elementary charge of an electron is the same as the proton, just opposite. So try to put that in your calculator and see if you get the answer that agrees with what's in your notes.